everyone. Welcome back to the M&E Drop-In. I hope you're all enjoying your day. Today, I'm joined by Alec Purdie from Quelfire, who is the technical manager there. Thank you, Alec, for joining me. How are you doing?
Yeah, good. Thank you.
I appreciate you coming down. Tell me a bit about yourself first. Why don't you introduce yourself?
Yeah, my name's Alec, technical manager at Quelfire. I've been there since 2020. That was brand new to the industry. I had a very good technical background, but passive fire wasn't something I learned. So I sort of jumped into the deep end and I've been quite passionate about it. And Quelfire have been very kind for me, helped me train me up, and I've managed to grow the technical team into something which I'm quite proud of. And I'm here to obviously share my knowledge from what I've experienced, hopefully. So.
Amazing. Thank you so much. Okay. Explain to the audience what Quelfire do. Who are they?
Yeah, so Quelfire are a passive fire protection manufacturer and distributor. They've been around for a long time, over 40 years. Predominantly, when they first started, they were more incandescent coatings and other things. But in the last sort of 5 to 10 years, we primarily focused on passive fire protection for service penetration, so your cables, your pipes, and linear gaps. And that's been our primary focus. And it's something that we've been very passionate about. So we've developed the products and the testing and sort of honed that area that we've become sort of the subject matter experts in that area.
When you say active fire protection, how does that differ from passive fire protection?
Yeah, so for anyone that doesn't know, in sort of buildings, usually it's a makeup of active and passive. So active is stuff like your sprinkler systems or your fire alarms, things that have a reactive purpose. They're activated by a buzzer or your sprinkler, the little glass breaks because of the fire, etc. Whereas passive are things that are built into the building. So not usually something you'll see. So your paint on your steel beams, your sealant around cables, you've got fire doors, that sort of thing. So stuff that's built in, that's just hidden in the background, but it's got a really important role. Whereas your active is, more the thing that the sprinkler will go off, the alarms, and people are probably more aware of that side of things.
Okay, that makes sense. Thank you. Now, explain to me, like I'm 5, how does the fire protection actually work? I know there are different products and solutions, I guess, but just how does it work?
Yeah,
maybe just give an example.
Yeah, I mean, there's two areas. So when we're talking about buildings, obviously fire protection, a lot of people will know about what's known as reaction to fire. So we all see the things on your sofas where it's like flame resistant. So it's the spread of flame across this table. But the stuff I do is what's called fire resistance, and there's a difference. So it's basically how a building will resist a fire. So when we're talking about passive fire, it's broken down into structural and what's known as compartmentation. So in your room, so for example, this room, if it was a compartmentation room, if the fire starts here, the walls, the floor should be able to stop that fire from spreading for a certain amount of time. So that's the main goal, is to stop that and then allow the fire service to arrive in a suitable amount of time. And if you think about hospitals or care homes, enough time that we can evacuate people safely. So that's the whole purpose about containing things which, and unfortunately the cables or the doors or the windows, they're all routes that the fire can take to get out of that room. So we have to suitably fire stop them using products, etc., which people might not be aware of, but are quite vital for the day-to-day of that building.
Interesting. Okay. Thank you. And okay, so obviously the obvious reason why fire stopping is important is obviously safety, just to prevent deaths and injury, obviously. But when it comes to M&E supports, how does fire actually affect the load capabilities of these supports?
Yeah, so a lot of people don't realize, especially with steel, metal. So you've got your cable tray that's got a lot of cables on it and it's being held up by the support. In a fire, because that steel is not protected by any coating or anything like that, when it hits about approximately like 550 degrees, which is very quick in a fire, and usually in the first 6 minutes or so, it will lose about 60% of its load-bearing capacity. So it starts to warp and bend. So it's really important, especially when we do our fire testing of service penetrations, that we use the right non-combustible service support, but also have it at a distance that's going to support the thing, because we test buzz bars or large trunkings to start to get really heavy units. And if you look at dampers, which is a separate thing than what we do, but again, the service supports are going to be vital. And it's what a lot of people don't realize. And if you ever get a chance to, if you see at the end of a fire test, when they take off the wall, the supports on that wall are usually all drooped warped, bent, because metal is a great product, but I don't think people realize that in a fire it can bend and warp. There's actually a good picture where there's a structural timber beam that's been designed that's then supporting the steel beam that's bent during a fire because steel gets so weak and stuff like that. So that's, it's very important that, especially for the M&Es, when they're looking at the service supports cables, the amount of plastic zip ties we see, that's not allowed near a firewall. It's got to be, an approved system, and it's got to be at a set distance. So it's quite important.
That's cool. Thank you. So I was going to ask this a bit later on, but since you mentioned testing, can you explain what is actually your testing procedure?
So for again, because it's fire resistance, there's different set categories. So for service penetrations, and sorry, it's a bit technical, but it's the standards for the UK and Europe is BSEN 1366 Part 3, and that sets out all the guidelines of how to test. So there's categories for cables. So we do what's known as different configurations. We tend to do the full cable configuration, which has ladders, trays, certain cable sizes that have been defined that would cover. So if we do all of them, it will cover all cables that are 80 mil or less, for example, armored cables, coaxial cables, that type of things. And then you've got conduits, which is a different thing, plastic pipes. So we follow that standard. So we tend to go to an accredited lab. So we tend to use Warrington Fire because it's close to us. But there are others like UL, etc. And we either use the wall furnace or the floor furnace, and then we will do some testing. So we'll stick plastic pipes for a wall, add a fire color, and then we'll test it and get a rating. And usually the rating we get is known as integrity or insulation. So that's integrity in sort of layman terms is the time it takes for the fire to get from one side to the other through any small gaps. But the one that most people forget about and the one that catches a lot of projects out is what's they're known as insulation. So that's the heat transfer. So especially when we start talking about cables or cable carriers like trays or trunking and busbar, because they have such high metal, especially copper, they're a great conductor of heat. And that's the sort of thing we have to try and avoid, that heat transfer, because if you get to, in our test, 180 degrees above the room temperature, so whatever temperature we start, that's known as an insulation failure. And that basically means there's a good photo where there's two panes of glass and one fire glass is stopping both the fire and the heat, and you can put your hand on it. But the glass to the right is just stopping the fire, and they put a cotton pad in front of it and it ignites.
Oh, wow.
So the heat gets to such a point that it basically skips the boundary and starts a secondary fire. So if you imagine you've got your sofa up against your firewall, which as a person living in their apartment, they probably don't even know which walls are fire and which ones aren't. That temperature can get to a point which your couch sets on fire. So that's another way where fire can spread. So that's catches a lot of people out, insulation, the heat transfer, and especially when M&Es, they like to use sort of metal conduits or metal trays or large cables. It's something they need to be aware of, that in some circumstances, especially when you need a very high 2-hour fire rating, that we can stop the fire, but stopping the heat is a real big challenge. And I think that's kind of shook the industry in a lot of places because they never really worried about that side of things.
Yeah, I think that's really interesting and useful to know in general, just for safety reasons.
Yeah, it's the big thing. It's like, obviously, fire doors, they're typically only tested for integrity only because they assume, and rightly so, no one's going to be stacking cardboard boxes. You shouldn't block a fire door. That's again, when you're at work and that risk assessment person's going, stop blocking the. There is a reason behind the madness. They're not just being irritating for no reason, etc. But that's the thing we have to look at. So there are circumstances where you can do a risk assessment. So like ducts and dampers, again, not sort of a field I cover, because they're usually quite high up in a building, you can't see them. They tend to often be allowed just to be integrity only. So stop the fire, not necessarily the heat. But with ours, if you've got a radiator with the pipes or cables, the EI is a big factor, and I think that's caught a lot of people out because they've just thought about they have to stop the flames, but it's the heat that's the big issue.
Yeah. Okay. So you mentioned the BSEN standard. Can you just tell me exactly what standards currently exist? So passive fire protection is broken down into certain areas. So like my main focus is service penetration. So that's
1366 Part 3. So that's a dedicated standard on how to test services and the different categories of pipes, cables, conduits. You have Part 4, which is another test that I do, and that's for linear gaps. So that's your small gaps at the top of the wall, the side of the wall. Doors have their own standard. Dampers and ducts, they have a variety of different standards. There are some areas that are still lacking behind. So cavity barriers are still one of the ones that are really struggling for specific standards, etc. And there's different ways to do that. And I know dampers have some restrictions, etc. So that's kind of why we're still in a bit of limbo, where BS476, which is the older standard, is still kind of around, but the government and people are talking about getting rid of it. But in certain areas, I don't think they're ready for it. But for service penetrations, I've never tested any test of BS476. It's always been to the BSEN standard because it's been around since 2004 side of things. But yeah, that's the standard, and it gives us the rules of what we can do, etc.
And when it comes to service penetrations, obviously there's so many different permutations. There's no way you can just test every single one. How do you kind of do that?
It's definitely been difficult. It's actually been one of the challenges, and I think it's been a challenge for a lot of manufacturers because a lot of people have just stuck to the norm and they've just not really got the feedback. So Quelfire, we're very passionate about getting the feedback from what's being used, what's new products. So when we do the testing, for example, plastic pipes, we're not going to test every size and every type. So there is guidelines to test specific ones. So the initial test we'll do is we'll basically fill a wall with different plastic sizes, and we'll find out what the 3 critical pipes are. Then your accredited body are happy that they're the 3 worst pipes with your products, just test them. So then moving forward, and that's why I try to explain to people that a test report is not really the right report to have, because you've got an 83 mil plastic pipe and my test report says 110 mil, and you're like, they don't match. But the accredited body, when they classify it and they put it into the field of application, will say, they'll break down all the pipe sizes, the wall thicknesses, and they give you the field of application because they can see all the relevant evidence, the critical pipes, the other stuff. So that's one thing. And the same with cables and conduits. With a conduit, very commonly used by MEPs, we have to test certain sizes, certain types. We have to have one empty, one with a certain cable size in it. So there are quite strict rules. And it's why we get updates. So my standard has just had an update in 2021, and it added a big change to the sort of things. So it included conduits, included buzz bars, and a few other things. So one of the things I've shared recently on my Knowledge Hub is people go, well, does that supersede your old evidence? It doesn't. So our 2009 evidence is still valid, only if it doesn't contradict. So there's some areas like the type of cables we've tested in conduits or on trays that do contradict, so we've retested and then reclassified. So there are some areas, but most of the time it's just an improvement on the old and that side of things. But it's very complex. What a lot of people don't know is I'd like to test everything, but one, it's very expensive, but also the standards don't give us enough guidelines. So a very common service type for any MEP out there is partial penetrations, which is your socket boxes or your conduits that only come out one side of the wall. That standard is still being written. That's Part 14. It's not even finished yet. It's been, since I've been in the industry, it's been in draft form. So other manufacturers have to test to the principles of other standards. So we test our socket boxes and conduits to Part 3 because that's, in my opinion, the most closely resembled standard. But the industry much slower than people realize that, you like to build modular and plasterboard ceilings, profile decks, but the standards just don't match what's there. So you might be surprised that a lot of manufacturers are struggling to test all their products to everything you want. It's not our fault entirely. It's just the fact that the standards just don't match the industry as a whole.
Thanks, Alec. That's really informative. I feel like I just learned a lot. Okay, so when it comes to obviously testing and compliance, how does this align with the new regulations, building codes and regulations, and also who in the supply chain does the compliance fall on?
No, it's a great question.
Sorry, no, 3 in 1.
It's a lot to digest, but to be honest, it's sort of the main one that everyone's kind of struggling on. So we've had the sort of the new Building Safety Act and the sort of regulations there. I'll be honest, there wasn't a huge amount of changes. I think people think there is, but I think a lot of it was more enhancing
And
what's already
enforcing,
there.
yeah.
And the enforcement. So the competency thing is the big factor. So from a manufacturer, there are regulations coming in about products, how we advertise them and stuff like that. Very similar for anyone that remembers when internet speed used to be said up to 70 megabits and all that type of things. There's got to be a bit more restriction on manufacturers and how they sell things and make sure that people, see the truth behind the claims. But yeah, the competency thing's big. And I think that's what's catching a lot of projects out, because the spotlight's been on, you used to have the main contractor who a lot of the time slopey shoulders. So they put the emphasis on the MEP designer, the architects or the fire stopper installer, and expecting them, well, that's your area, you be in charge. But now with sort of the designated roles, you have what's known as the principal designer or the principal contractor. They're going to be the sort of key people. So on some of the projects I'm working on now that are new builds that are going into the Gateway 2 process, which is higher risk buildings. That's one of the big changes, is the higher risk buildings, like over 7 stories, they're going through this gateway process. They're having to really change the way they do things. So we're having a lot more early engagement conversations. But they have the principal designer, which has been sort of designated by the client, but they know that they don't know everything. So they've got the MEP designer, they've got the architect, they've got ourselves for service penetration, the fire door, they've got all the specialists that help give them all the information. One of the things I like to sort of do analogies for people. So if you sort of look at it as a wedding cake, and this is how I look at a building, which people think, oh, it's a bit strange, but at the end, you want a very nice, happy groom that sees a very nice, elegant wedding cake. But if you actually look at how that was made, it wasn't just someone walked in the kitchen, started chucking things in a bowl and mixing it. There's coordination, there's preparation, there's understanding of how things blend together and work well. So it's that understanding of a building where before it was very much, let's start building, start digging, start chucking things. There's a hole there, I'll chuck a cable through there. And that was what was missing, is that sort of structure and guidance to go, we want a wedding cake at the end, not an eaten mess. And I think it's shocked people in the industry. It has really greatly shocked them, because the competency thing it's kind of a sort of double-edged sword. People getting a bit sick of that word, but it is really important. It's knowing what you know. And if you don't know, it's not being sheepish and hiding behind, is getting that information. There's plenty of people out there, hence, with this podcast alone, people are willing to share that knowledge. So, ask and listen and learn, really.
Amazing. Thank you. And obviously under that competency comes obviously knowing also selecting the right products. So when it comes to fire stopping, what factors should be considered to choose the right product? And also kind of what problems can arise from mixing manufacturers?
Yeah, no, it's great. It's a great question. Again, obviously I'll try and focus it on the service penetration, because it might be different for other manufacturers. But it's actually something my technical team struggles quite a lot, because we'll just get the most basic question, and it's, like, I have a pipe, how do I seal it? We need more information now, because I need to know the size, the material, like we talked about. A copper pipe is sealed very differently from a plastic pipe. And although you may think a copper pipe is suitable, when we go back to that heat conversation I had earlier, a copper pipe conducts heat more than a plastic pipe. So just because something's combustible versus non-combustible, in fire resistance, it's not the big factor. Reaction to fire, and I understand the cladding aspect, well, that was a concern, but for inside your rooms, sometimes plastic, especially for a conduit, for example, you get a better fire resistant rating with a plastic conduit than you do a metal conduit often, and not. So there's really questions. But again, I like to use analogies for people that might think, oh, you're just asking loads of questions, but I'll throw something back to you. If I bet you that I'll give you £1 million to jump out of an aeroplane with no parachute, what would you say?
I would say no.
No. But then if I told you, okay, but the aeroplane's on the ground and I'll pay you £1 million to jump out of it, you might be a bit, maybe, because if it's one of those big jumbo jets, I might break all my legs. But then if I then give you some more information, told you it's that really tiny little plane that's only 4 foot off the ground, and your answer changes because you've been given more information. That's the problem when I'm told I just have a pipe in a wall that, okay, here's my 300 details. I've got a plastic pipe in a single skin plasterboard wall and I need 30 minutes and it's an oversized hole. Here's the one detail. And it's people getting that sort of realization that the more information you give me, and it's quite important for the MEP side of things because they're now getting on projects where they go, oh, we've just got BCWS, which for me, I know that's boosted cold water supply. But for the uninitiated, they don't know. And also, we're starting to see MLC, which is multi-layer composite pipes, copper, steel. So just because 20 years ago, it was assumed it's going to be a copper pipe in phenolic insulation doesn't mean it is now. So yeah, the more information we get, help me to help you. That's the sort of main thing from it.
That's a really good tip. Yeah. You touched on plastic, it being a misconception that plastic isn't necessarily always good for fire, but it can be better than metal in some cases.
Yeah. So again, obviously I don't want to go too down the rabbit hole with people, but so there's, in fire, there's two aspects. So if there's an agreed sort of stages of fire. So with fire, it normally starts with what's called the ignition. So if we imagine someone back in the old days, you had lots of adverts of people smoking in bed and you drop that cigarette. So that's going to set fire to your bedding. So, and then it's going to start to grow. It's going to encapsulate, your pillows and all the other bits. So that's the first part of a fire, and that's what's called reaction to fire. So you don't want the table to be able to spread the fire. You don't, So that's where the cladding on, say, Grenfell, which obviously was a horrible disaster, was bad because it allowed that spread of flame. So it had a really low, bad reaction to fire. But when we talk about the next stages, so which is the flashover and basically this whole room's now engulfed in fire, we're talking about how we resist it and stop it from getting out. So just because something's non-combustible doesn't mean it's the right thing, because a single copper pipe going through the wall is non-reactive, so it passes reaction to fire test is A1, but from a fire resistance, it will stop fire, but it will let the heat through in less than 20 minutes. So if you had a requirement for 60 minutes, that copper pipe's failed. And that's why you'll tend to see like locally interrupted foil face rock fiber, and that might look a bit strange. Why is there a small section of material on each side of the wall? And that's purely there to stop that heat transfer. So then you've got to factor in that cost. So the copper pipe on its own might have been one price, but now you've added that. Whereas if you'd had a MLC pipe where you simply sealed it with what's called a HPE sealant, like one of our products, when that fire hits that pipe and it melts, that product closes up the hole, and that stops the fire and the heat. So actually, you could have just used the MLC pipe and it gives you a much better fire resistance performance than the copper pipe without any additional products. As such, it's those sort of factors where people get confused between reaction and resistance. And in an external envelope, I understand the concept why you need to worry about reaction, but in a room, I think that's where people need to realize that sometimes, for example, I know for 2 hours in a partial penetration, you're much better to have a plastic conduit dropping down to your socket box than a metal one. But I also know from a socket box perspective, if you wanted to be in a kitchen where you want two socket boxes together, which is very common, we have microwaves, etc., it's better to have a metal socket box because they can be close together, whereas plastic need to be further apart. So again, that's how complex it gets. Something so small as that. Whereas this is why it's vital that at the early engagement stage, they reach out and go, this is what we would like. Can we do it? And yes, but you might need to tweak this and this. And that's where I come in to help out a lot of people.
So what you're saying, what I'm getting is that whether you prioritize the reaction to fire versus the, what was the other one? Resistance to fire depends heavily on just the situation and the project.
The requirements. So obviously, the sort of, if your main requirement is what's known as compartmentation, so you want to stop that fire, especially in a care home, you want to be able to restrict that fire so you've got time to evacuate a few people. So there's quite a bad fire that happened in Crewe, which is actually quite close to where we're based. And I think that fire happened back in 2019. And what a lot of people don't realize was the fact that it was a nice summer day like it is outside now, a lot of the residents were already outside. If that had happened in the nighttime, the way that fire spread through the building, it would have been devastating. It's why it's being investigated so heavily, and there's criminal proceedings happening, etc. Because it was just simply the fact that there was no huge loss of life, but it had that thing because it had no compartmentation. And again, it could be the fact that most people are now complaining, saying, "Oh, it was made out of timber frame." But that's a misconception, because timber frame can provide you the right thing. You know, walls, especially with plasterboard, and there's a lot of time, especially in load-bearing aspects, going back to structural, that the timber will support the wall and the load longer than the steel that's unprotected. So there's a misconception there. The big problem that was the simple fact that no one had thought about the compartmentation. They'd either used outdated guidelines such as the 40 mil rule and the 160 mil rule in approved document B. But yeah, that's the sort of thing. It's a complex thing, and anyone that doesn't think it is really is going to struggle in the future, I think.
So what other, apart from that, like what are some other misconceptions you see often when it comes to fire? Like,
there's lots of different things, but with services, I think there's a lot of misconception that you can just stick anything into one opening. So for a lot of people, they might not realize that metal ducts and dampers, they have their own standards, going back to that. So they should always be in their own opening, but you'll often see cables together, or you'll mix things like air conditioning units for MEPs. They'll have copper pipes with Armaflex type insulation on them with cables on a tray, which is really easy for them to route around the building. But I know for a fact that you'll get only 20 minutes heat resistance insulation. So there's misconception that everything can be fire stopped and everything can be fire stopped to a certain level. That's the big sort of challenge. And also that everything's tested. Going back to the earlier point, we have limitations. So one of the things that we've only just done in the last 2 or 3 years is gone away from just concrete floors. So concrete floors, solid concrete floors, is pretty much what all manufacturers that sort of do the same products as us have tested. But you're seeing profile decks, which is the one with the crinkly tin, as people call it, underneath. You've got hollow core, which have big holes in them. And even starting to see timber, like plasterboard, and those systems haven't been always tested. So it's things like that, whereas it's not even just about the service types. Architects say, I've got 30 minutes, I'll stick up a single skin plasterboard wall. The damper might not have been tested, the fire door. And sort of going back to actually one of your earlier podcasts with Paul, there's too many people blinkered. You've got to look at the bigger picture. And that's where I think the principal designer, there's a lot on his or her shoulders, but they need those experts. You need the wall manufacturer. You need the fire door, the damper, ourselves.
It's all about collaboration.
Yeah. It's that. Obviously, we talked before, but that's what I think the big word for this year needs to be. Competency was overused last year, and I think people are a bit sick of it. It's important. It needs to be followed. Yeah. But I think people need to realize that you're going to reach the competency by collaboration, because I don't know everything. Every day is a school day. I use that quite a lot, and I'm always learning. And it's the reason why I wanted to do this. Was I've learned a lot from the MEPs as vice versa. So there's certain things now that I know that we're testing to, because it has an impact on cables and things. So talking about that heat transfer thing aspect before, there's a lot of copper in cables. So we often, to get 2-hour fire rating, will wrap them in foil face rock fiber, which is great. We can get a fire rating. But what I didn't realize until working with MEP designers is that has a real impact from a thermal perspective of the cable. So they have to do further calculations. They might even have to change the type of cable, the size. So that was impacting us. There's certain things when we looked at gas pipe work with sleeves that, I've had to collaborate with people outside my sort of field of my bubble as such, and sort of work together. So even as I've been doing testing with the R&D team over the last few years, we've changed and adapted and looked at, going back to a metal socket box, for example, most manufacturers only test plastic. Now the plastic normally sits in the face of the wall because that's a couple of little clips, whereas anyone that's used metal, that sits on a metal caddy bracket, usually within the wall. And often or not, when they put the dry lining up, there's a gap between the socket box, and no one had accounted for that. And it's a very minute detail, but it has a detrimental effect on the fire. So we've had to go and do testing that replicated that. So we allow a socket box 5 mil behind the plasterboard, then you extend the putty pad. But it was the feedback and the collaboration that got us that information. So without that, I think the industry is going to really struggle. We need to start working together and
No, it makes sense. It's like with anything, when you realize when you talk to people how much you don't think those. things that you just would not think about. So yeah, collaboration is really important. Can you give me other examples of like challenges that you might face, but collaboration or particularly early engagement could prevent?
Yeah. The big challenge obviously is the mindset of people. So more often not, because they've been building, they've been really heavily reliant on maybe the installers of products or other people that they've been in the industry a long time. They may have some knowledge, but just because you've done something for a long time doesn't necessarily mean it's the right thing. So it's trying to, the big challenge is probably change that culture and understanding that although it may seem longer when you first do it, the early engagement side of thing, and you're like, well, why do I need to give you the insulation type and all this? There is a method to the madness. The main contractors and even the MEP designers that have started heavily working with us, the first project may have been, problematic, long, struggled, because we're all learning. Anytime you learned something at school the first time, it was long and hard. Practice makes perfect, as I'm a firm believer in that. And they're finding now where they've taken that. And the ones that started, there are some main contractors that started implementing things 2-3 years ago, long before they had to. And they're way ahead of the game. Now, the ones that have now realized, the Building Safety Act is here and I need to start acting, are now wondering why nothing's working, why they're struggling, why they can't submit for the gateways because they're too nervous that they're going to get rejected. And that's the biggest challenge. Is culture is not really I sort of hate that word. I think behaviors and understanding that just because you did something for a long time doesn't mean it's right. And although this may seem like people, there's too much regulation, there's too much
actually
things.
Helping you.
Yeah, it will help, and it does. There are things. I'm not saying the Building Safety Act is perfect, far from it, but I think it's a good foundation that as we do this collaboration, we all work together, that everyone starts to put their input to say, well, we've tried to do it as best we can that way, but we're limited because of this factor, like, the test standards, and again, I know obviously there's the pros and cons of Brexit, but one of the pros for Brexit was we're not essentially tied in to the EN standards now with the BSEN, but that we can, if we need to, start to sort of separate. So an example of that is in BSEN 1366 Part 4, which is linear gaps. There's a national annex, which is for the UK, to allow us to do some testing around fire door frames. And that's a way then, as a manufacturer like myself, because I predominantly work in the UK, that we can do some extra testing to get that information out in the field. So there are some sort of restrictions, because otherwise you have to get 27 countries to agree. And that's why the standards take very long, that we can maybe adapt and bring the UK a lot forward there as well.
I think a lot of it also just has to do with accountability and knowing where your limits are as well. So at what point should the M&E contractor recognize, okay, this is now I should probably contact a fire stopping specialist? Yeah, no, it's
a great question. Actually, one that I've been trying to work on quite a lot with behind the scenes with M&E to try and work out the best stages, because there is a sort of structure called REBA, which has different stages. So often or not, the M&Es get brought in like stage 3, maybe stage 4, and they start running their routes. And that actually is really kind of where they first need to engage with a specialist, because no matter which manufacturer you work with, there are rules. So a project I'm working on recently, the M&E they've been doing it for a while now. I've just gone, okay, I know I've got sort of BG's walls, plaster walls. They have set rules for aperture sizes, spacings, and that side of things. So they've got those rules. They've asked us, okay, what sort of rules should I follow for services? So we've given them, and I've worked on what's called golden rules for that side of thing, because if I was doing every rule, which I'm trying to put into a document, it'll be pages and pages. So I'm trying to keep it simple. I'm a very firm believer in that. But then they also need sort of the damper rules, the doors, because there's door jams. So there's just to start running your routes it's not feasible, because even if you start going through blockwork walls, there's structural aspects that, they may need lintels over a certain size and that. And then when you start getting close to the head of the wall, there's deflection requirements. So there's such a big area that anyone that starts at REBA stage 3 just starting to run their routes and not taking into account the firewalls or even acoustic requirements is kind of basically going to find it the hard way that they're going to suddenly get to REBA stage 5 when it's the more technical area going, and I go, that's too small, that's too big, that's too close. and you've got to redo all that work, which could have took weeks and months. They have a much harder the job than me just saying that's too close together, etc. So it's getting that knowledge of going, okay, what's the initial rules? So on the projects that I found being quite successful, they get the initial ones, they run what they can, and 90% will be okay. And then there's going to be certain key choke points or areas that I've tried my best here, I can't work to all these rules. Then we have that collaboration meeting, and that's where I've been doing a lot of meetings where, okay, I've given you these golden rules, they start to work to our minimums. But on the flip side, we're just talking about design here, it's then the installers, because it's got to be practical. There's no point me saying something, it looks good on a piece of paper, that the person who comes along goes, well, I can't physically put my hand in there, or, there's no access from that side of the wall because it's a shaft wall and stuff like that. So yeah, it's hard, and we're still trying to work it out, but I'm finding that I'm being brought in a lot earlier than Reba stage 4 or 5. And even if it's just the initial, hi, yeah, if you need me, I'm around.
Yeah.
These are the sort of rules I would follow if I was you. And even guidelines on, okay, you may want 20 mil thickness insulation because that meets your thermal requirements, but my test evidence needs it to be 25 mil when it goes through the firewall and stuff like that. So it's just giving that heads up.
Yeah.
You may like that, but you need these factors as well, and vice versa. They may give me rules saying, well, I can't put foil face rock fiber because the cables are wrong. Okay, let's use a trunking system. So the protection is around the metal trunking, and then there's fire pillows inside the trunking. So instead of a tray, you go into a thing. Or again, with air conditioning pipes, they want them on a carrier. Okay, you've got a tray, doesn't work, but if you put on a basket, you get a better fire rating. And it's just those simple things. But yeah, it's hard. It's not an easy answer, but that it's more engaging. And I'm hoping with this podcast that people realize that, if they want to speak to me, I'm always happy to help.
I think they will. You've been quite helpful. When you're mentioning these golden rules, do they differ per customer that you speak to, or? Yeah. They're sort of not per customer, but the rules are very specific to my products and evidence. So, okay.
So what we test, because we are very focused on service penetrations, for example, we test the worst possible case scenario. So very often we'll have the service with our product 0 mil from the edge of the letterbox. And the letterbox is your builder's work opening. For example, if we're testing that, we'll have clusters. So we'll have 3 plastic pipes together in a cluster. And we have things like very close together, but on a test furnace, it's a bit easier to install these products. But the reason why we do these worst cases is because it gives you the biggest scope. When it's classified, you'll get the largest field of application. So that's why we try to do it, and also give us a bit of freedom. What I don't recommend that the MEP starts trying to work to all this minimums and the worst case, because you're going to have too much congestion. It's not going to be practical to install. So my golden rules, working off my products, are 3 basic rules. So if you stick, and it works for about 98% of our products, but really it's quite simple. If you leave 50 mil space from the edge of the aperture, so from the edge of your tray to the edge of the opening, 50 mil between 2 trays, so services of the same type, and then 100 mil between your sprinkler pipe and your tray. And if you follow those 3 general rules, are quite simple for your builder's work hole when you're running your routes, then when you start to include the Quelfire product later on, there's enough tolerance built in that for 98% of our products, there's a couple of examples where it doesn't work, that you're not impeaching the minimums. And it's also a lot more practical that the fire stopper can get the fire back in there. The M&E can install the service ports all spaced out correctly, etc. So it's just those golden rules. They seem very simple, but it's just something that's not been sort of fathomed, because some routes, the tray is 500 mil wide, so the builder's work opening is 500 mil wide. So where's the fire pack going? Where's the other products? So I know it may seem like, you're making it bigger to sell products. It's not. And for anyone who's never tried installing fire back into an opening, try it, and then you'll see how hard it is. And some of these fire stoppers have to get their hands into 10, 20 mil. And that might sound a lot, but we're talking 1 or 2 centimeters if you take off the 0 for millimeters. So people need to realize how small these spaces are. So it's that type of thing that matters quite dramatically on these projects.
While we're on the topic of M&E supports and spacing, what's the best practice around the positioning of your M&E supports, and how far should it be from the firewall, and what are the risks associated if you don't follow that?
Yeah, no, it's a great question. In fact, it's probably one of the biggest issues and challenges in the industry at the moment is, and it's been around for a long time. People don't realize, again, we're talking about that enforcement and just making people aware. So when we do a fire test, and this is manufacturer specific, so it's very important that, again, that early engagement you speak to whichever fire stopping manufacturer's products are going to be used is the first service support. So be that your cable tray support or your pipe clamp has to be non-combustible unless it's been tested. So using a plastic zip tie is a no-no. And it has to be at the distance that was tested or closer. So when we do a fire test wall, we tend to have the first service support 400 mil.
Okay.
And that's both sides. So you can have the support 400 mil or closer. Others maybe 250, 150. So that's why it's manufacturer specific. Now I know a lot of people say, can we have it further away? There are restrictions. So example, for a cable tray, we cannot go past 500 mil. There's rules because obviously not going too down the rabbit hole. The cables in the tray are usually only extend 500 mil or so each side of the furnace. So we have to add weights because you imagine in real life, the cables continue. There's a lot more weight in a real life scenario. So there is some science behind the mandate. So we can't go further than that. And it's also not practical for the furnace because there is only so much depth of the furnace that we can go to. The big service that gets caught out quite a lot is sprinkler pipes. So the CPVC ones, they allow sort of 1 meter spacing between the supports. So they start doing that and they're following the manufacturer of the pipes guidelines, but they don't realize that walls matter. And the reason why it matters, going back to sort of our earlier conversation, is that even though it's still, and you could probably do, pull-ups on it, etc., when it gets in a fire, and very quickly, we're talking usually within the first 6 or 7 minutes, the temperature is going to get to the point where it starts to lose its structural stability. So it starts to bend, warp, and move. And this is why we have to do the testing. So it's very important that you follow the test evidence and meet those requirements. So again, that early engagement, which manufacturer are we using? Quelfire, I can have 400 mil or less. Manufacturer B, I need 250 mil or less, or 450. So it's that sort of importance. And it's a huge thing. And building control, especially as they have a big emphasis on their knowledge and experience. This is one of the things they've been pulled up on that they weren't flagging, and they're doing it. And fire stopper installers as well, they turn up to site looking up and going, that's not right, get the MEPs back in here to do it. And then you're having to come back in and do lots of rework, which is costly and effective, but also, it could be detrimental on life safety as well. So it is a key factor. And if it's hard to show here, I wish I could show some pictures, but I'll, if anyone needs it afterwards, message me. And I've got some examples where you can see the back of a furnace afterwards and the devastating effect on the supports. I mean, when we test something like buzz bars, they are extremely heavy. I've seen tests where they're not supported correctly and it rips the whole wall down during the test because they just get so weak. They go, that you imagine that in a real life scenario, you're sat here, 5 minutes into the fire, the whole wall gets pulled down because the service has dragged the material down. So yeah, it's very important, but it's something that the knowledge is out there. Just ask us and we'll help you.
Cool, thank you, Alec. I feel like my brain's expanding by the minute. So just to go back, when you were talking about your golden rules and why spacing is so important, can you just explain why is it so critical and how can it actually affect the performance of fire stopping? Yeah.
So with service penetration, it's vital that you follow the rules. There are obviously other areas where spacing is important, but for example, especially when you're starting to look at like large fire ratings. So one of the examples I can give, so if you look at our plastic conduit detail, we've done a test on. So we've done a 63 mil conduit, very common with cables. And when we did the first test, we had a cluster of 3. So the conduits are 0 mil touching each other in a sort of triangle formation. That's one of the ways we can do a test. And then we did the HPE seal around the cluster as a collective. And we did the fire test, got 2 hours integrity. So we stopped the fire for 2 hours, but we only got 60 minutes insulation. So that means after 60 minutes, the heat got so much through those copper cables and that you failed insulation. So that's a good detail for EI60, but where you've got EI120, so that's 2 hours integrity insulation, couldn't use that detail. So what we then went and did the same test, but simply just separated those 3 conduits by 50 mil between the seals. So each one had 10 mil HPE around each one with 50 mil. So we're talking 5 centimeters between each one, and it blitzed 2 hours. So that's simple of just moving slightly. So that has an impact there. And the same with sort of cables and pipes, same with plastic pipes. Because often or not we test worst case scenario to try and give you those smaller rules, there is an impact. Things can interfere with each other. Certain products, so some of our products are intumescent, so they start to expand and they can push out other things or things. So spacing is vital. And it's, again, matching the test evidence. There are rules that say that the spacing has to be as per tested. The aperture should have the minimum amount of product. So we talked about 60-40 rules in some of our knowledge hub pieces, but that was quite outdated. So some manufacturers, they just test an individual specimen. And then they have another one 200 mil away. So they're restricted to what's known as section 13.7. That gives you the guidelines. So if you've not tested clusters or things closer together, your minimum spacing is 100 mil. So again, that's where it's vital to look at what not just the product and all of that looks the same as product A and product B is, what's the testing behind it, what's the field of application as such.
Interesting. So you can, it makes sense. You wouldn't use a product different to its purpose and how it was tested. What else should M&E contractors look for in the test data?
Yeah, especially for service penetrations, it's a bit of a minefield out there for them. So it's challenging because things can look the same. You know, you look at one fire bat, which is normally a rock wool core, sort of rock fiber density core with a ablative coating. That can look the similar as manufacturer A and manufacturer B's. They are probably made up differently, different densities, different chemical coatings or whatever, but it's not necessarily the product. Just because it looks the same, it's how it's been tested. And again, you have then start to have limitations. So it's going back to the earlier thing about where I think a test report, the terminology, I need to see a test report. With service penetrations, it's pointless because it's not really, it's a snapshot of what a product did on that day, and that's it. So it's the next step. So for those that don't know, I do testing, I do multiple testing. We get those reports, we send them off to an accredited body. That accredited body looks at the evidence. In our test standard, there's field of application rules, and then they define the scope of application. So we've tested some things, and you look at it and go, why are you testing it that way, or why? Because if we test that, there's science that says, you know, we've done that. So for a lot of people, they don't realize we test on plasterboard walls. You can use all that evidence on blockwork and rigid concrete because they deem that wall is more onerous than this wall. So there's what's called an interchangeability. So we test on a 100 mil thickness and you can have a 200 mil thickness because it's not practical to test absolutely everything. But again, it's getting that evidence. So very common one that happened to a lot of people a few years ago was single skin walls are becoming more and more popular where you only need 30 minutes or 60 minutes because those walls are now being designed that one layer of plasterboard, which saves a lot of money on projects, can achieve what maybe 2 layers did 10 years ago. But the test evidence didn't match it. So most products have only been tested on double skin walls that are 100 mil or thicker. So we had to go away and do single skin walls that were 75 mil wall and done a lot more testing. So again, you could look at 2 products, but your application might work with product A, but not product B. And that's, again, where you need to move away from necessarily the cost aspect, value engineering. It's with fire engineering. So going back to my thing about give me all the information, and I will say, and one of the things our technical team would say is, yes, here's a tested solution. You can do it for that. No, you need to change X, Y, and Z because, you know, the rule's not right or something like that, or C, sorry, we can't help you. That's way too far outside our field of application. And it's that early engagement to find out you're going down the right path. You know, something simple as plastic pipe for a profile deck floor seems simple enough, but there's very limited products out there that have been tested in that floor system of that pipe. So it's finding that balance. So I think people need to realize it's more about looking at the test evidence and the technical documentation than the amount of people that look at a product data sheet and go, oh, it says up to 4 hours. Okay, but your wall's 60 minutes. What's the fire collar going to do? Float in midair? It doesn't work that way. You know, you need to look at the application, provide that information, and we look at it and go, yes, or we go, no. And that's where I think the big change in the industry comes from.
Okay, but what do they do when the services have already been installed, like retrofit projects? What are the considerations then?
Yeah, no, big problem. Again, I've probably said that quite a lot on this podcast, actually, big problems. But yeah, so remedial side of things is quite a troublesome thing at the moment because there's a sort of double-edged sword. So there are times where we can say yes to things. So you might be looking at assessments. So again, going back to the way we've tested worst case scenarios. So there might be some of the test evidence I've got where you could have cables mixed in with other services or closer than 50 mil, or you can do stuff from single side access for a certain fire rating. So there are possible solutions, but there are a lot of things where we're seeing on a lot of projects they're having to go back in and move services and add first service supports or just do things in the right way. I mean, it's not necessarily just things that maybe the MEP's done by services too close. There are things like they may have put a damper in an opening with other stuff at the time, thinking it's fine. No one's told them it's not, and the main contractor hasn't said anything. So that now needs to be looked at. Mm-hmm. So it could involve doing ad hoc testing. So there are a lot of older projects that are having to build the specific issue they've got on site and then do testing. So there are sometimes when I'm at the test labs where you're seeing strange and wonderful things being built and you're like, why are they built? But it's because they've done that, unfortunately, on a building. So if you can then get the test evidence to prove it's okay for that project, then fine. But yeah, it's not an easy challenge, and especially with the rules that for older builds, I think they're covered up to 30 years, but any new build now, even if you think you've done it right, you're still liable for, I think, 15 years. So anyone can come along, and I know on a couple of projects recently where someone living in the building has removed some blocks and noticed there was no cavity barriers in certain areas. So they've raised the alarm, and now the whole building's having to be re-inspected. In some of these areas, going back to that passive fire active, these passive fire measures are really hard to get back into those areas once they're installed, like cavity barriers or even service penetrations if they're above a roof ceiling and stuff like that. So it's vital that when you're doing new builds, you get it right and document it right, which, that's why record keeping is really important. But for remedial, for some that think there's going to be an easy get out of jail free sort of card, it's unfortunately not the way it works. There are going to be times where you are going to have to move things. You may have to look at testing. And even from the aspect of access, there are times where the main contractor don't want to give you access to both sides of a wall, or you've only got access from the underside of a floor and not the above. That really hinders what fire rating you can get, because it often only lets you have 60 minutes or only works for certain products. So this sort of, or we don't want to panic people, or we can only give you access in certain areas, I think that needs to be looked at as well. So remedial is probably a whole nother podcast, I'll be honest. It's not going to be easy, but for the M&E out there, I think that's, again, understanding these things that we're talking about, that we're not just being awkward. First service supports, they're vital. That's why they have a spacing distance. Someone may have accidentally put the wrong product around your, talking again about CPVC pipes. People might have it's an acoustic wall, so they've just put acrylic sealant on it that has chemical compatibility issues. There's a lot of factors. So I think the why is important. So if the MEP are sort of aware of these considerations and challenges when they're approached, and also from their perspective, when they're told, we need first service supports, but we can only do one side, they can go, well, actually, no, the rules state it's both sides. So, we all work together, and that main contractor really has to go, okay, I need to set aside this budget, give you the access, and understand the whole bigger picture for it.
Yeah, like there's so many things that I didn't realize to consider, which again is why early engagement and collaboration is so important. Yeah. What about high-rise buildings? Are there any unique challenges that they present?
Yeah. So the Building Safety Act did introduce sort of what's known as the gateways, and that predominantly at the moment is aimed at buildings that are defined as higher risk, which at the time I think a lot of people were trying to sort of bend the rules to either come under the height or not be 7 stories and that. But I think people need to start realizing that this is just the start. So there are rules. There are, first of all, you have the gateway submission. So for all new buildings, and it's started now, the new ones are starting to roll in. I know of a couple that have already just started. You have to do Gateway 1, which is the initial thing where checking fire safety access and other aspects there. And that was brought out quite some time ago. I think it was 2021 when it first rolled out, and it should be pretty much an easy stage and something that everyone was already doing. I think they had something like a 60% fail rate. And it's still not fully people passing that stage. Gateway 2, which is what's being implemented now, is a full design proposal. So that means you go to the building safety regulator and go, this is the building I want to build. And it's not just fire. This is all aspects from your, thermal, your, the air quality, everything has to be there ready. This is what we are going to build. And they will check all the regulations, not just for fire, but obviously that's a big, important aspect of it, and go, yep, we are happy, you can build. And then they start to build. And then Gateway 3 is you've done the build, you've got all your records, which are obviously very vital, that then you hand it to them and go, yep, we've built it, and this is what we've built. And they check and make sure that Gateway 3, they just go, you said you were going to build this, did you build this? And they go, yeah. And if you did, they give you that occupation certificate. And I don't think people realize it's quite a long phase. So at the moment, Gateway 2, you're looking at 3 months to have that design possibly checked, because they're quite delayed because of outside influences from a certain company went bust, and they're having to jump in to solve over those buildings. But then Gateway 3 can be longer. And if you get any pushback, you then have to go back to the back of the queue, offer that evidence. And it's not until you get that occupation certificate that you move anyone in. And you could be, up to 12 months after the building has been finished. So again, that's when main contractors need to start realizing and budgeting and this time frame that for higher risk buildings, you need to incorporate this, and getting it right first time is vital. And the only way you're going to do that is early engagement, getting the right design, getting that collaboration, and then the record keeping to be able to hand it to the BSR, because they're not going to be looking through. They want you to go, do you meet this building regulation? Yes, here's my homework to show that I do, not scrolling through things, etc. So I think that's the big challenge. But those that think it's just going to stick to higher risk buildings, I think are in for a nasty shock, because the way I see it is this is the foundation. These are the worst case buildings we need to work on now. But eventually it's going to be all buildings, because for anyone that's starting to see design and then building, they're seeing they're finishing on time, they're finishing on budget, and ultimately they're not worried that in 5 years' time someone's going to pick something up and they go back. It's safety. So I think all buildings eventually will go down that route.
On the topic of record keeping and the handover process and the evidence, what is actually the right way, I suppose, to keep all of this evidence?
Yeah, I mean, everyone has their own way of doing things, but the sort of golden thread of information, which was one of the new things of the Building Safety Act, is, again, it wasn't a new thing, it's an enhancement. So there's been something called Regulation 38 that I think's been around since 2005. So it's a building regulation, everyone should have been following it, and that's at the end of the building, you've got to give all the information to the owner, the occupier of the building. So no one's been doing that. So now where, for example, that case study I mentioned earlier, where someone's taken off the brick and seen no cavity barriers, they've gone back to look at all the records to say, well, did the fire stopper take photos? And there is no record. They've got nothing for the building. So now they have to go and do a destructive inspection, which is costing lots of money. You're having to move people out and disrupt their lives because there's no records. So there isn't any sort of right way to do it. But one of the ways I'm seeing it quite heavily, which involves different people, is sort of incorporating. So MEPs often do a schedule, so they know what services are going in, which are opening. Okay. So it's being expanded. So the ones I'm seeing now is we get all that information, and it's good now that I'm seeing, it may say type BCWS, but it'll say material, copper, lagging, phenolic thickness, this aperture size. So I know it's in a 500 mil by 400 mil. And then the architect is adding in, it's going to be in partition 01, which is a double skin wall. They've added the fire rating, the acoustic rating. So you're getting all that information. Then Quelfire then able to add, okay, because of all that, you'll be looking at this detail. This is the first service support. This is the spacings. And you're starting to get all that information that anyone that inspects it walks up and goes, builder work hole number 1, should have a cable tray, should have an insulated metal pipe, should have fire bat, there should be this, and it has all the information. So then even in 10 years' time, when someone has an issue that, you decide you're in a new apartment and you want to get Sky TV installed or anything like that. The MEP comes along and wants to start putting in cables that they know, firstly, all right, can I do it in that area? They know records to keep. They should really be reaching back out at, say, for ourselves, if it's our products, okay, can I put this cable there and it's not going to impact what's already there, and stuff like that. So it's having that information that everyone stays knowledgeable. And it's, like I said, it's an enhancement. The golden thread is much more in depth than the Building Regulation 38, but it's always been there. I think people just weren't aware or knew about it, or for some people they just, we didn't have to do it on the last project. Why do we need to do it on this project? But yeah, record keeping is going to be a big thing. It's all going digital. And again, it's just working with, MEPs have their own software, fire stoppers, architects. But again, it's that collaboration that we all need to work in a way that we can all put it into one system that works. And the ones I've seen work very well are schedules, get the MEP information, the architects, the fire information, and then I can narrow down from 300 drawings, details to one, because I know straight away you've got, a copper pipe with Kingspan core and it's 40 mil thickness. Okay, that's going to be this detail that uses our quell coil. You need first service support, 400 mil. And then here's the 3 golden rules for the spacing. Everyone's happy. Boom, boom, next. And it sounds like, that just seems so simple. It is that simple. You just need to get that mindset of provide the information, do a little bit work at the start, and then the build should hopefully run smoothly.
Which again would be helped by collaboration as well.
Yeah, massively.
Okay, for one of the last questions, can you give any examples of real life situations where either improper installation or product selection has affected the performance of the building? Or fire stopping part?
Obviously, a lot of people are quite familiar with stuff like Grenfell and stuff like that. But there is one that people don't aware of. It happened even, I'm old, but it happened even before I was around. So I'll do that one, but I'll give a positive one afterwards. But a lot of people obviously are aware of Chernobyl and that incident with its devastating. And this is the problem where, because disasters are sometimes averted, people don't aware of things. So in about, I think it was 1975, there's the Brown Ferry nuclear power plant in America.
Okay.
And they had a massive fire due to wrong products. So cable trays in the wall had been sealed with PU foam. So anyone might be aware of that. That's the fire foam, pink foam that's used, very often wrong around service penetrations. Most people are aware of that now. It's sort of flogged to death on LinkedIn that the fire foam has never been proven for service. But what people didn't realize, this is a nuclear power plant. It sealed all the cables. And I think someone went up to them with a candle to check that they weren't letting any smoke through. It caught on fire and started a fire. And I think the fire spread that much through the building that they were about 10 minutes away from a nuclear meltdown. So that, purely by using the one product, obviously there's other factors in that, but the compartmentation was in such a way that, they were minutes away from a full-on, basically a Chernobyl type incident. Yeah. So that's quite an important one, which shows you that, and you think in those type of buildings that safety and sort of design had been thoroughly thought out, so it can happen to anyone. But I think another positive one, again, going back to where people don't sort of understand that this stuff does work if it's done right. So everyone's obviously fully aware of the tragedy of Grenfell that happened. What people might not be aware of is, like, I think it was a week or 2 weeks after that, in Birmingham, there was another high-rise building fire that started, I think it was an arson attack at the time. But the reason why it wasn't overly reported was because, unlike Grenfell, the compartmentation there, so the passive fire protection and obviously the active as well, worked. It kept that fire on the floor. Most of the residents didn't even know there was a fire in the building, and that's where I think, obviously we see the negatives. I like people to realise that it is important to see it, but I think sometimes the positive needs to come out, that people know, okay, there is ways to do it right, and we can avoid these tragedies if we just follow right. And if you review that, I can't remember the name of the building, but the fire service even complimented the compartmentation, saying it was purely one of the main factors that kept that fire contained. One, it keeps them safe going in that building, but most of the people didn't have to move out, go into hotels and stuff like that. So it does have a detrimental effect, but it also, I wanted to, just show people that it can be done both ways.
That's a really good story. I mean, if that doesn't make people want to take it more seriously, then I don't know what will. Okay, great. This has been honestly such a good episode. Thank you. One last question that I always ask is, what's one thing you would change about the industry if you could?
It's a difficult sort of question, but the main thing for me, I think, and this is actually one of the reasons why I wanted to come on the sort of podcast, and certain things I do at Quelfire that it's not my day-to-day job, but I like to share my knowledge, is the behavior thing and the knowledge. I think people need to realize their limitations. You know, we don't know everything. Learning what you don't know, but it's being open enough to go and find the answers. You know, there are times where I don't know the answer, but it's not as simple as to say I don't know. I'll go, I don't know, let me try and find out the answer. And it's that back to that collaboration thing. So I think the biggest thing I'd like to change is that everyone has that right behavior and mentality of, okay, we may have done it in the past this way, but this is the new way. We're going to learn and we're all going to work together. So I think if we can overcome that, the skills and the knowledge thing, that will come in time. We can get that. But I think until we get that behavior thing sorted, I think the industry is at the moment got its sort of brakes on, because we're getting a lot of resistance for people not willing to change. They don't want to change. They don't want to put the effort in as such. It's not going to be easy. It's going to be an uphill battle at the start, but we will get over that summit as a collective. And I think we'll see in 10, hopefully 15 years time, better buildings. And we'll look back at all this and go, what we were worried about, type things. So that's what I hope, and that's my challenge, if I could change. So.
I completely agree. What a wonderful note to end the episode on.
Thank you.
Thank you so much, Alec. It's been great talking to you, and I've learned a lot.
Thanks for having me.
Yeah, you're welcome back anytime.
Cheers.
So thanks, everyone, for watching. I hope you learned a few things. I know I did. And don't forget to check out our other episodes and check out Quelfire's socials. And yeah, I'll see you next episode. Bye. Wow. Oh my gosh.